Hello guys. Let's wait until 9:05, then we'll start the class. Morning everyone. It's 9:05 now. Let's get started. And let's have a recap on what we have covered last week. Last week we talked about if-else statement. And what is an if-else statement for? It's for it can check the condition, whether the condition is true or false, and then it execute either true some kind of statement for true condition and some kind of statement for false condition. So this is something like a flow chart of this if-else statement. So if it is hot weather, then we execute something. If it is not, then we execute something else. And in this case, it's return, is exit. And other than if statement, we talk about else statement. So that means if the condition is true, we execute something like a statement A. If the condition is false, then otherwise, this is a else statement. We will be executing this else statement. So this is an example, a sample code. What if you have more than one condition? Like you have 2 or 3 conditions, then now we can utilize else if. So this is an example. If weather equal to sunny, then we execute something. Else is weather equal to something else, we execute something else. Else is if weather equal to like something else again, then we execute another thing. And if none of the above match, then there will be a else statement as a default case. So for this else statement, we can do something else. And other than the above if, else if, and else control structure, we talk about type conversion. So there are two types of type conversion. The first type is automatic type conversion. So you don't have to worry too much about this. This is handled by the compiler automatically during operation, like during calculation. And there is another type which is called force type conversion or explicit type conversion or typecasting. For this type of type conversion, we actually write the code by ourselves. We manually convert the type of the variable. So this is performed by us. There's a sample for this. For example, so this is a very classic sample. If you have 100 and you divide by 3, it should be a floating point number 3.3333 something. But in this case, A will print out 33. Why is this so? Because this has something to do with the type system in C++. So 100 is an integer, 3 also is an integer, and their result will still be an integer. So the decimal points is lost. The decimal part is lost. Only the integer part preserved. Therefore, A is 33. So in order to make the, like to ensure that the calculation is conducted in floating point number, in floating point format, we can manually add a type conversion to it to add a type casting. How to add a type conversion to it? We can transform this 100 integer into a floating point number by writing float and then this parenthesis. Wait, what is this called? Alright, I forgot. What is this called? It is called parenthesis. Yes, correct. So add float and then a parenthesis, and then this is telling the compiler that you are forcing the type conversion from integer to a floating point number. And now when you print out A, the result will be 33.3333. Also, we touch a little bit about binary system. For this binary system, I think you guys already learned about it in your mathematics class. So how to calculate a binary number, convert it into base 10, or from a base 10 number, how to convert it into a binary number. There's a few examples over here, but generally you can refer to your mathematics class. And why does we use binary number or binary formats in computing so often? That's because binary number is the most intuitive way to represent the computer state. Because you need to, we know that computers like CPU are just circuits. And they are formed by something like transistor. And when the circuit is on, then we get 1. When the circuit is off, we get 0. So it's very more intuitive to represent this kind of state in binary number in 0 and 1. That's why in computing, we use binary number very often. And then we talk about operand size. So we need to know that there is a storage limit in our computer, right? It's not unlimited. So we have to be very careful in how we utilize this memory, our memory space. Therefore, in all our in all the C++ type, they occupy different kind of space. For example, if it is if it is a Boolean number, it occupies 1 byte of space. If it is a character, it occupies 1 byte of memory space. If it is integer, occupy 4 bytes of space. And if it is float, it occupies 4 bytes of space. But if it is double, it occupies 2 times the space of float. It's 8 bytes. That's why double can store longer decimal number. Also same for integer and long. So integer, long can store longer integer than integer type. So they are actually both integer type. That in mathematics sense, they are both integer. But long can store longer number than integer because it has a larger storage space. And then we talk a little bit about the debugging tips. And pretty much that's all about our previous lecture. So we talk about if, and else statements. And then we talk about type conversion. And that's the core of last lecture. So in today's lecture, we will talk about for loop and switch. Switch is something like if, else, and if statement, but it got very tiny difference, but it's very similar. So if you already understand how to use if, else, and else statements, so switch will be very easy for you to understand. And we'll talk about something very, very important. The very, very important thing is this loop structure. It's called a for structure. So this helps a lot in building something that is actually useful, that can actually be used in real life. So it's this for loop. Okay. And I'm sorry that today's slides is not translated because for some reason our translator haven't translated yet. So today's slides will be in Chinese, but I will try to conduct this course still in English. Yeah. Also, by the way, if any of you have any questions, feel free to type it in the chat section, and I will take a look at the chat section and maybe reply to your questions. And if you have any questions, you can ask in any language, like both Chinese and English, and maybe Malay. Would you send this slide to the website for self-learning? You mean our platform, this coding bar platform? Okay. Actually, I'm not sure because this is not up to you. Sorry, this is not up to me. This is up to the management. So I will ask them. So ask them about this, and yeah, maybe they will upload it to the website, or I'm not sure. But if we do upload it to the website, we'll inform you in the WhatsApp group, or we'll talk about it in the next lecture. Yeah. So let's get to the switch statement. So first we talk about if, else, and else statement, but when there are a lot of cases, for example, there's a sample as below. This is a very complex logic flow. If A greater than B, then if C greater than B, and if C greater than 0, then do something else, do something. So this a very complex logic. And sometimes with the help of switch case, we can make this kind of logic simpler, and the code will look simpler and look cleaner. So that cleaner is something very important in programming, because if your code is cleaner, that means if there's any error, very easily you can notice it, and you can change it, you can update it, and you can fix it. And it's also easier for others to understand your code, or maybe it's easier for you yourself to understand your code as well. Because after you return your code for 1 or 2 months, you forgot what actually your code does. So if your code is cleaner, it's very helpful in reduce errors and to maintain it. For competition, maybe making the code cleaner doesn't it's not so important, but in real life, in development, a website or a mobile app, it's very important to make sure that your code is clean. And let's get to this switch statement. First, you can take a look at a flowchart first. So there's a switch case. So if case A, then we execute something for the statement A, and then break. Break means we are going out to this end of the switch. Okay, and then if case A is not true, you're going to compare case B. If case B is true, we are going to execute the statements B, and then break. Break means we are going to the end of the switch. And if none of the above match, which means condition doesn't match, then we go into the default condition. We execute something also, and then we end the switch case. Okay. Why would there be a break here? So this is because at least in C++, if there is no break here, this statement will continue to execute the statement below. So after we execute statement A, we will continue to execute statement B. We will continue to execute the default statement, and then it will go to the end of switch. So most of the time, we simply just add this break statement here to break out of this switch structure. Okay. So this is a demonstration of this flowchart. If there's a switch condition, so if this condition match switch case A, then you're going to execute statement A and break an end of the switch. Otherwise, if case A doesn't match, then we're going to compare it with case B. If case B do match, then it will be the end of the switch case. And if case B doesn't match, you're going to run the default case. And after the default case, it will be end of the switch. This is a code sample. Actually, it's something like a template. There's a switch keyword, a pair of parentheses, and then your condition. So this condition can be like A greater than B, and then this will be is A greater than B. This will be a condition, and this can be true, and this can be false. If true, execute something. If false, execute something else. Also remember to put a break over here. And there also will be there could be a default statement as well, a default case. For this default case, you have other codes to handle this default. You can have other code to handle this default case. For example, so our case is a number over here. So for each of the number we match, if 1 is matched, we print out something. If case 2 is matched, we print out 2. Otherwise, by default, we print out 0. Here we can, let me demonstrate it in our platform. Yeah. Integer number. Let's say this number is something we need to read in. And then switch number. Case. If number is 1, print out 1. And line and break. Case 2. If number is 2, we print out 2. Case 3. If number is, okay, how about default case? For default case, we print out 1,000. Okay, we can add a break over here also. Okay, so let's enter a number. For example, 0. For 0, it doesn't match case 1 and it doesn't match case 2. So default case will be executed and it will be 1,000. How about 1? If I enter 1, 1 is being printed out. How about 2? If I enter 2, 2 is being printed out. How about -1? If -1, 1,000 is being printed out. What if you say, okay, yeah, what's the functionality of break? So this is what I'm going to talk about next. What if there's no break over here? What will happen? You can make a guess in your mind what would happen if there's no break. Because just now in the slides, we're talking about break makes the code return to the end of the case. If the code doesn't return to the end of the case, for example, let's run it 1. Okay. Wait. Yeah. So 1. You say I enter case 1. Case 1 is matched. So 1 is being printed out. But then 2 is being printed out as well. Because if there's no break, the program will continue to execute all the cases below. So after this is being executed, this will be executed as well. And then after this is being executed, there is a break here, and thus this switch structure is ended. Let's try it out. If we remove this break as well. Okay, 1. So this will be executed, this will be executed, this will also be executed. And for the last break, it doesn't matter because this is already the end of the switch structure. So either you put a break or you don't put a break, it doesn't make a difference. What if, let's say, I enter 2? What will be executed? Will this be executed as well? So no. If it is case 2, case 1 doesn't match, but case 2 match. So we execute the code of the statement for case 2. And then because there is no break over here, the program will continue to execute the default case. Okay. So if there is a break here. And we run case 2 again. You see only case 2 will be run. The program below it won't be run. Okay. So as you can see, it's very simple, right? Switch case. It looks very, very similar to if else. So we can actually convert switch into if else. Okay, you can convert it into if else. If, so in this case, if number equal 1, print out A. Okay. Else if number equal 2, we're going to print out 2. Else, otherwise, if none of the above match, then it will be the default case in switch, equivalent to a default case. And we execute a third one. So they are basically the same thing. So don't be afraid. If you really can remember a structure for switch case, you'll be good. Just use if else. That's good enough. You don't have to know switch. But switch is something good to know. Sometimes it makes your codes simpler or looks cleaner. It's something good to know, but not necessary. If else actually is enough. It's because it's exactly the same as switch case. Also, okay. And I think pretty much that's all about switch. Okay, how about you say, what if in your statements you want to you want to calculate multiple things. You want the program to do multiple things. It's not just one line. It will be multiple lines. Is this allowed? So this is allowed. You can do something like A equal 10 and A integer B equal A plus number, and then you wanna print out this B. So let's run this. Sorry. Where's the question? Where's the problem? This. Okay, so here for case 1, if you have multiple lines, do remember to add a curly braces. Okay, so add a pair of curly braces, and then you can have multiple lines. And in our case, I enter 1. So 1 is being printed out. And then I define A as 10. So B equal 8. 10 plus 1 equal to 11. So 11 is being printed out. And then there is also an if. There is a if structure over here also. If number is 1, 1 will be printed out. So everything looks good so far. Okay. Yeah, also there is another tip. I think I didn't cover it previously. So there is a tip for multi-lines and single line. The difference in their syntax. For example, if you have multi-lines in this if statement, for example, you have multi-lines like this. Then you must cover it in between these curly braces. But what if inside your if statement, there's only one statement? In this case, actually, we can simplify, we can remove the curly braces actually. For this case, there is only one statement here, all right? So you can remove the curly braces as well. And now let me comment out this code for switch so that I can demonstrate this one. And enter number 2. So still it works. It's basically the same thing as if you have these curly braces. So this is a special case. For one line, if you have only one statement, you can remove these curly braces. But if you have more than one statement, you must cover all of your statements inside these curly braces. If you have more than one statement like this. So these are considered two statements. One, if you have one semicolon, so the rule of thumb is if there is a semicolon, then this is a statement. And this is a statement as well. So there are two statements here. And if you have more than one statement, you must cover your logic inside a pair of curly braces so that these logic are tied to this if. Okay, that's the tips about structuring single statements and multiple line statements. Sorry, not multiple line statements, multi-statements, multiple statements. And so there's some explanation in our slide. Switch and then a condition. And then in between the condition, it has to be a parenthesis. And then after that, write a pair of curly braces. So inside the curly braces will be your core logic. Inside a logic, for case 1, you can do something and then break. For case 2, can do something as well and then break. And then there can be a default case. And so there is a simple explanation of break. Break means jumping out. So for example, in this case, that means if this case has been executed, now we wanna jump out of the whole switch structure. So let's break. So we jump out of the whole switch structure and we are here now. Yeah. So break is for executing, sorry, is for exiting from the switch structure. And how about default case? So default is like the else statement in if else structure. Default is the fallback one. So if none of the above match, then we match with the default one. Also remember, after case and then your condition to match, remember to add this what is this called? Double colon. To add a colon. And for default, also remember to add a colon. And so here is saying that the curly braces is a must because yeah, just have to memorize it. The curly braces is a must. And then after you write this case keyword, there must be a space between your case and your condition to be matched. So remember there should be a space over here. And after this, there should be a colon. And break is for jumping out of the switch structure. So default is one of the cases. If none of the above case match, then we're going to execute the default one. And there's another sample here. Let me try to copy paste it. Hmm. Okay. Paste plus print out something and then break. Case minus print out something and then break. Case times. Okay, so there's a typo here. Should be sign and demonstrate this. Try run. Let's run this. Sign. So I enter plus 3 plus 5. So this sign is a character and character is supported. If it is plus, then it prints out 3 plus 5 which equal to X. If it's minus, how about 5 minus? 3 minus 5 would be minus 2. And times would be 3 times 5 would be 15. How about divide? 3 divided by 5 will be 0. Why is that so? Because, remember, actually, in mathematics sense, it should be 0 point something, right? But it's 0 because A is an integer, A is an integer, B also is an integer. So after this division, their output, their result will be cast into an integer as well. So the decimal point part is lost. Only the integer part is retained. So how can we avoid so? We can make a floating point number. Thus, this operation will be taken out in floating point format. And thus, a floating point should be printed out. Let's try it out. Yes, a floating point is printed out. So 3 divided by 5 should be 0.6. What if we enter something else, like 0? So it will be the default case. None of the above match. So now the default case match. 表达式有误. And also there is another, no, okay. I think that's all for this demonstration. So I hope you get the idea. We can match an integer or we can match a character. And if the case is matched, can command the program to do something. And there is an example. So a homework here. We'll cover it later in the next session after 10 a.m. And so that's all about switch case. That's all about this switch structure. We are going to learn something more exciting next. So previously we already talked about a lot of syntax thing like C out, C in, input output, and the declaration of variable or assignment of variable and operation, calculation, expression, a lot of things. And if else statement, switch statement. But then, so if you were given a task to print out a lot of repetitive content, how would you do so? But just by what we have learned so far, we actually are unable to do something very repetitive. For example, I want you to print out this string 10 times. So are you going to write C out 10 times? It's not practical, right? You have to count one by one. Also, like count, is this 10 or is this 11? You have to make sure that it's correct. So it's not practical to do repetitive tasks like this. So there's something better. There's another syntax for this. It's called for loop. So loop is like running across or running around the fields. And we can command the for loop to run like 10 times, 11 times, to run until an exiting condition is matched. And just as a side note, so we need to know why for loop is important. For example, when will for loop be used in our daily life? So is there an example? For example, it's like your CPU. Your CPU is keep refreshing, is keep executing new commands. So this is actually an example of for loop. That the CPU is like never end working. It's keep working. So every time it's accepting some kind of command and then it executes it. So this is like an infinite for loop. So this is one of the example of why for loop is that important. Okay. And in the for loop, there should be an initialization stage. After that, there should be a condition. There should be a condition. And then there should be the for loop statements. Those statements that you want to execute inside for loop. And after this statement is being executed, because it is called a loop, right? So we're going back to the condition checking again. If the condition checking is true, we execute these statements again. So that's why this is called a for loop. It looks like something keep happening and never ending, unless this condition is false, then it stops. Otherwise, it keeps running. And yeah, as just we have talked about just now, if the condition is false, then we stop executing the for loop. So we exiting the for loop. For loop, first, you write the keyword for, and then you write a pair of parentheses. And then we should write this curly braces for all the statements that you wish to be executed in this for loop. And this will be for this part, for the first part, we will be assigning a value to our variable. And then there will be a semicolon and we get to the second part. For second part, this will be checking whether we need to execute this for loop again. And then write a semicolon and we get to a third part. For this third expression, we are increasing or decreasing our variable. I think we need some example. For example, this is a good example. So we initialize a variable, a control variable. we initialize this variable as 0. And then and then we are telling the compiler that as long as our controlling variable, that means as long as I is lesser than 10, we are going to execute this for loop. We are going to execute all the statements over here. So for this case, I equal to 0, and because for the first times I is 0, 0 is lesser than 10. So this will be executed. And then every time after this is being executed, the third part will be triggered. We are going to plus 1 to I. So now I will be 1. So now I will be 1. And then because I is lesser than 10, right? So this will be executed again. The statements will be executed again. And then after the statements are being executed, we are going to increment I by 1 again. So this go on and on until I equal to 10. When I equal to 10, now I is not less than 10. And thus, this for loop ended. And this won't be executed again. So this I is something for calculate how many times your for loop to be executed. And usually we start it from 0. Doesn't have to start from 0, but usually we start it at 0. And you doesn't necessarily have to name it I. It can be anything. It can be number, can be J, can be K, can be count, can be anything. And doesn't necessarily have to start from 0. So there's an explanation for it. For what I've explained just now is the same thing. If I is lesser than 10, the loop will be continued. If I is greater or equal to 10, that means I is 10 or I is 11 or something greater, then the loop will be stopped and we continue execute other code below. So every time before we execute the codes between these curly braces, we'll compare this condition first. Only if this condition match, then this will be executed. And after the statements are being executed, now we will run this part, the third part. So now I will be I equal I plus 1. And remember, for your first part, second part, and third part, remember to separate them by semicolon. This is very important. You must have this semicolon. So let's try this. What is the output of this program? I equal 0, I is less than 10, I plus plus. Let's try it in the platform. Do you have something in your mind already? So in the beginning, I is 0, right? And 0 is smaller than 10. So I will be printed out. And then after I is being printed out, we are going to execute I plus plus. So now I will be 1. So when I is 1, 1 is smaller than 10. So this will be executed. So now 1 will be printed out. So if you run this code, it will print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Until I is 9, when we print out I is 9, when I is 9 and we print it out, now we run I plus plus. So I will be 10 now. When I is 10, and now we are going to compare to check whether we need to run this loop again. When I is 10, 10 is not smaller than 10. So we are not going to run this loop again. And thus, only 0 to 9 will be printed out. So basically that means we start counting from 0 and we stops at 10. And while I is equal to 0 and I is less than 10, we print out 0 and I equal I plus 1. And then for next round, I is 1 and I is still smaller than 10. So we print out 1 and I equal I plus 1. So this is the second round. So there's a third round, I equal 2. So until the 10th round. For 10th round, I equals to 9 and print out 9. And then we execute I plus plus, which means I will be 10 now. When I is 10, I doesn't lesser than 10. So it doesn't match this condition. So we exit this loop. So this for loop is ended. Thus, 0 to 9 will be printed out. And so back to our first sample. We want to print out 人之初性本善10次, sorry, 10 times. So we can have this loop structure. For integer I equals 0, I smaller than 10, I plus plus. That means this will be executed 10 times, right? So even though this ended as 9, you need to remember that it starts at 0. So this is actually 10 times. 1 to 9 will be 9 times, plus 0 will be 10 times. So this will be executed 10 times. So 人之初性本善 will be printed out 10 times. Let's try it by ourselves. Yeah. If you want to be really sure, you can write something like I times. Yeah. Should be I plus 1 times. So first times, second times, until 10 times. There is a practice also. It's in our platform, so we'll go through it also later. What if you want to print out 0 to 9? If you want to print out 0 to 9, this is an interesting question. So now we can make we can initialize I as 9. Okay. And then you want to print out 9 to 0, right? So it should be from greater number to a smaller number. It should run descendingly. And thus the condition should be greater equal to 0. That means we count until the number 0. If it is lesser than 0, then this loop should end. And then for each round, we are going to minus the variable by 1. For each round, I minus minus. So this for loop will print out 9 to 0. Let's try it by ourselves. Initialize I as 9. And we are going to print out I as long as it's greater or equal to 0. And I minus minus. Print out I. So first round we print out I equal to 9. And then for each round we minus I by 1. So until So we minus I until I is 0, we print out 0, and then we minus I again. Now I is minus 1. If I is minus 1, it is not greater equal to 0. Thus, this will not be executed, and the follow is ended. We can print out I here. Final value. Final value. Do I have a type also? So this, okay, so there's something to take note of also. You see, we are initialize I inside this for loop. And that means I is not visible outside of this for structure. I is only visible inside this for structure. So if you want to make this integer I visible to outside, to the outside program, you can define I here. So we declare I here, we define I here, and it can be used in both for loop and it can be used in the outside program as well. Otherwise, previously the error is I was not declared in the scope. They cannot find I because I is declared in the for loop. Okay, so final value is -1. These are all some sample practices in our platform. We'll go through it later. So I think that's all for today's lecture. We can take a 5 minutes break first. At 10:05, we'll start go through some of the practices and homeworks. So let's take a break. See you later and at 10:05. Hello guys, it's 10:05, so let's get started. In this section, we are going to go through some of the practices or some of the exercises and homework in our coding bar platform. So let's take a look together. Basic training, chapter 2. Basic training, chapter 2. Okay, we finished chapter 2. Now we are going to start chapter 3. The first question would be, please design a program where the user enters a positive number, 1, 3, 5 something. If the number equals 1, print Monday, equals 2, print Tuesday, and so on. If it exceeds 7, print Cyclops is hungry. So this question is asking us to allow the user to enter number. So obviously we need to use C input, C in to read the number. So now after that, you can utilize the switch case, the switch structure. If the number is 1, for case 1, it prints out Monday. For case 2, it prints out Tuesday. For case 3, it prints out Wednesday, and so on and so forth. And if none of the above match, we can print out something else as a default case. Let's try run this. For case 1, prints out Monday. For case 3, it prints out Wednesday. For case 7, should be Saturday. Oh, sorry, Sunday. How about for case 0? The Cyclops is hungry. And actually, you can write this, implement this in if else also. If number equal 1, it's just a demonstration. Number equal 1, print out Monday. Else if number equal 2, it prints out Tuesday. So else if number equal 3, and okay, so and then until else, which is the same as the default case, we print out Cyclops is hungry. Yeah. So if case and switch case are mostly the same thing, it looks a bit different, but logically they are the same thing. Submit it and we pass. Let's take a look at the second question. So this question is asking to print out from 1 to 10. It's very simple. Very simple, right? This is almost the same as the sample in our slides. So we can initialize I equals 0, and then in this for loop, sure, we can initialize inside for loop as well. So we declare our variable inside for loop and we initialize it as 1. And as long as I is smaller or equal to 10, we are going to print it out. And every time we execute this loop, we will increment I by 1. And we run it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is being printed out. Okay. It's another question. They want us to print out 10 asterisk symbols. So how to do so? First, we can initialize an integer I first. And then inside this for loop, still we have to initialize it again. This is the something like a template. Always we initialize a variable and then the condition for executing for loop, and then either increment or decrement to a variable. So from I equal to 0 to I smaller equal to 9. Now we are going to print out start. From this sample and slice already we analyzed it just now, right? It will be executed 10 times. So this is what it wants. Just run it and 10 asterisks will be printed out. Let's submit it. It passed. Please complete a program with the following functionality. The user enters a positive integer n. Print all positive integers from 1 to n. Each number should be printed on a new line. That means user can enter any number, 10, 100, 1,000, and we are going to print out all positive integers from 1 to this n. So first, we have to read this number, right? So C input n. And before you read a number, remember, always you need to define it first. So here we define integer n, and we read it. And then we want to print out all the numbers from 1 to n. So we can initialize our I as 1. And then while I is smaller equal to n, we will print it out. And every time this for loop run, we are going to increment it by 1. And let's run this. Let's say we want it to be, our n is 8. So 1 to 8 will be printed out. What if our n is 100? So 1 until 100 will be printed out. What if we want our n to be 1,000? Yeah, it's valid as well. So 1,000 numbers are being printed out. See, it's very, very powerful. You're right. You just pass in this n, and this program does a lot of things for you. Can execute it 1,000 times. Okay. Submit. It's successful. Please use a for loop to complete printing. Multiples of 3 between 0 and 100. This is telling that we should print out all the multiples of 3 between 0 and 100. How can we do so? We can utilize the percentage, the modular function. So if a number is a multiples of 3, this number modular by 3 will be 0. That means the remainder after divided by 3 will be 0. Okay. So that is the idea. And now we are going to loop between the number between 1 and 100. If this number can be divided by 3, if this number can be divided by 3, that means the remainder is 0, right? I mean, can be fully divided by 3. The remainder will be 0. So that means this is a multiples of 3. And if it is a multiples of 3, we are going to print it out. Okay, so let's run this. And all the multiples, 3 between 1 and 99 are being printed out. Submit it, and it's successful. Let's take a look at the fourth question. Observe the following sequence and use the loop to print all the numbers. So the sequence are from 4 to 268. Each number should be printed on a new line. Okay, so we can start our loop at I equal 4. And then we stop at I. We want us to print until 268, right? So stops at I smaller equal to 268. And the pattern is all of these are off by 11. So 4 plus 11 is 15. 15 plus 11 is 26. So this is the pattern. So in order to print this I in this pattern, we can pass I by 11 every time when the loop is executed. So now, in the first round, 4 will be executed. 4 will be printed out. And then I plus equal 11. That means we plus 11 to 4. Now I is 15. So 15 will be printed out at the second round. and so on and so forth until when I equal to 268. And try to run this. So 4 until 268 are printed out. Okay, to another question. Please design a program that allows the user to repeatedly enters 5 numbers and displays the result of tripling each number. What does this mean? Enter 5 numbers. Oh, okay. So we want the user to enter 5 numbers. For each of the numbers, we are going to times 3 and print it out. How can we achieve this? Can make use of the for loop. First, we want the for loop to run 5 times, right? How can you control it to run 5 times? So it's very simple. Initialize your I as 0, and then while I is smaller than 5, it will be executed. And every round, I plus plus. So this makes sure that our loop will run 5 times. And then for each time, we want the user to enter something. So we use a C input to read and end. So the user enters something, and then we're going to print out this number times 3. So let's try this. If user enter a 3, we print out 3 times 3 equal 9. If user enter minus 12, we print out negative 36, about 33, 69. 0 times 3 will still be 0. 7, 7, 7, print out 2, 3, 3, 1. And that's pretty much all for this question. So let's submit it. And successful. And then this question is asking for, it's a bit similar. A program that allows the user to repeatedly enter 5 grades. And then we count and display a number of grades above 59 and the number of failing grades. So this question is similar to the previous question. We have to repeatedly read input from a user. So first we need a for loop to run 5 times, right? To read 5 grades. So inside this for loop, which in our I starts from 0, and the condition is I smaller than 5, and the control is I plus plus. And every time in the loop, we're going to read in a number. If the number is greater than 59, we want to store this number somewhere else. We want to store this count. So here, I created an integer to store this count. So this means how many persons pass the count, pass. This means how many persons fail. So if n greater than 59, that means it passed. I'm going to increase this pass count by 1. So pass count plus equal 1. And otherwise it fails, right? I'm going to increase fail count by 1. And at the end of this loop, we are going to print out how many people pass and how many people fail. For example, our input would be 1, 25, 33, 80, 13. 1 passing, 4 failing. So this question is actually quite straightforward, but it makes use of if else, it makes use of for loop, it makes use of C in, C out, and it makes use of verbal declaration and verbal also it makes use of verbal increment or verbal assignment. So this is a very helpful question to practice your understanding on all of these concepts. So this pass. Now we have another question. Okay, this question is a bit special. It's asking, so already they return all the code. Now what we need to do is to remove some of the redundant code or some of the incorrect code so that the system can correctly display the following results. So the system should be displaying 1 plus 1 equal 2, 2 plus 2 equal 4, 3 plus 3 equal 6, 4 plus 4 equal 8, 5 plus 5 equal 10. Okay, let's analyze this. Initially, A is 1 and I is 1. And I will be executed until 5, until 6. When I is 5, it will still be executed. And every round, we're going to increase I by 1. So initially, I is 1. A also is 1. So 1 plus 1, we're going to print out 1 plus 1 equal. So this is correct. This is also printed out 1 plus 1 equal. So we can only pick one of these. One of these have to be commented out. But which one should be commented out? Let's think. Let's analyze more. And then here will be A plus plus. That means A will be 2. And then we see out I plus I. I plus I will be 1 plus 1 will be 2. Is correct for first round. But if A plus plus, A would be 2 plus 2 equal 4. So maybe we shouldn't have A plus plus. Or we should have A plus plus. So one of the, how about we try this? We print out A plus plus. Here it prints out 1 plus 1 equal 4, 2 plus 2 equal 3. This is obviously incorrect. Okay. So how can we make it correct? This is actually a fun question for you to think about. This is something like really a fun question. Can play around with it. 1, 2, 3, 4, 5. So I think because this 1, 2, the prefix 1, 2, 3, 4, 5 are exactly the same as I. So this one, we should comment it out A. We should print out the one from I. And then still is the same, but if we remove the A plus plus, now it's 1 plus 1 equal 2, 2 plus 2 equal 2, 3 plus 3 equal 2. This is incorrect also. What if we print out this as I plus I? What will happen? 1 plus 1 equal 2, 2 plus 2 equal 4, 3 plus 3 equal 6. So this is correct. Prints out I plus I, and so we just use I and we didn't use A at all. So now we make it correct. Just commented all the codes related to A. They are not helpful. And let's submit it. Submit it, and this is the last question. Let's take a look at the homework question. The first question. Actually, we covered this in the last lecture. So last lecture already we talked about this. We allow the user to enter today's day of the week and then enters the number of days passed. And then the program will calculate the day of the week for that day. So for example, user enter 2. 2 means Tuesday, and then enters X. That means after X days has passed, it should be a Wednesday. Okay, the output should be 3, it should be a Wednesday. And how can we do this calculation? It's a mathematics question actually. So it will be so I read the current day first, and then I read how many days has passed. And the current day plus how many days has passed modular by 7 will be the day that we want, will be the output. But why is there a -1 and +1 over here? This is because when the user entered their day is from 1 to 7. But their day is 1 to 7, right? Monday to Sunday. But in order for this modular to work, modular maps a number. If modular 7, it maps a number to 0 to 6. So this format, this number range doesn't work with modular. In order to make this works, we have to make it 0 to 6 as well. Okay, how to make it 0 to 6 as well? So for our date, we are going to -1 to make it 0 to 6, to make the range 0 to 6. And then after that, we're going to do the modular calculation. After that, we map it again. To 1 to 7 range. So to map it again, we can +1. So this is the maths behind this question now. And then after that, we get the output, right? The output will be 1 will be Monday, 2nd will be Tuesday, until 7, and there's a default. And this will be the switch case part. The switch case is actually quite simple. The hard one is the mathematics calculation. You have to build up have to observe the pattern and come up with your own mathematics expression. Let's submit it and pass. And okay, there is a question also for this reset. Based on the following for loop syntax, what should the content corresponding to the numbers be? Please drag the appropriate answer into the box. The first part would be initialize, right? So it will be variable initialization or assignment. How about second part? Second part is condition checking. It's checking whether we need to run this for loop. So which one match it? An expression that generates a Boolean value, the statement that should loop normally where the counter increment or decrement goes. So for second, it should be this. It generates a Boolean value so that we can compare. So this for loop we compare. If it is true, if this Boolean value is true, we will execute the statements below. If this Boolean value is false, this for loop will end up. And task 4 is the simplest one, right? The statement that should loop. These are the statements. And third one will be the increment or decrement. This is where we update our variable, our control variable. Yeah, and submit this. Okay. And then there are some more questions, and we'll go through it next week. This is pretty much all about this week's lecture, and next week we'll completing the lecture on for loop, and then also we start to touch while loop and break and continue syntax for while loop. So while loop also is a loop structure. From its name you can know, right? While loop also is a loop structure, and it's a bit similar to for loop, but with a bit different. It's like if else and switch. They are very, very similar in their logic, but a bit different in their syntax. So yeah, stay tuned. Next week we'll continue to talk about for loop, and we'll start talking about while loop. That's all for today's lecture. Thank you for listening, and see you guys next week. Okay, bye-bye.